Hello there. This is a quick debriefing of the third problem from the online homework set that you had here. And there's there are problems like this in the Stewart textbook as well. This is about using average velocities to get instantaneous velocities. Set up here is if a ball is thrown straight up into the air with an initial velocity of 80 feet per second, height in feet after t seconds is given by this formula. First of all, find the average velocities for the time period beginning when t equals 2 and lasting 0.5 seconds, 0.1 seconds, and 0.01 seconds. And then we're going to use that to guess the instantaneous velocity at time equals 2. Now the most common mistake that students make here is just not thinking very carefully about what the two time values are during which we're calculating average velocity. Average velocity is always the distance that is traveled between one time point and another, divided by the time that's elapsed. So we're going to have to think about, first of all, say for this part of the problem here, what two time values are we talking about? The mistake here is to let one of those time values be time equals 2 because it says so, and then you see 0.5 seconds and think that the other time value is 0.5 seconds. Okay, now that's not what the problem actually says though. It says find the average velocity for the time period beginning when time equals 2 and lasting for 0.5 seconds. Okay, so not between time 2 and time 0.5, but starting at time equals 2 and lasting 0.5 seconds. So what are the two time values that we're talking about here? 2 seconds and then 0.5 seconds later. So the second time value is 2.5 seconds. Right? Take an example from real life. If I say that my office hours begin at 1 o'clock and last for half an hour, then my beginning time is 1 o'clock and my ending time is not like 0.5 hours, but 1.5 hours. It's a duration. That's what this is right here. This is telling you how long the time interval lasts. So to answer part A, I'm going to have to think about the average velocity between these two time periods from time equals 2 to time equals 2.5. If you just plug in 0.5 into this formula up here and start churning out average velocity values, you're going to get a result that's just way, way off. Okay, so my average velocity from time equals 2 to time equals 2.5, just like we saw in class, that would be the position at the ending time minus the position at the starting time divided by the ending time minus the starting time. Again, we're looking at an interval of time that begins at time equals 2 and lasts for 0.5 seconds. Okay, so these two here. Now, just really quickly, I will save some of the calculations here. Y of 2.5, if you put 2.5 into this formula here, you should come up with 100. And y, excuse me, y of 2, if you put that into the formula up here, you should come out with 96. And then 2.5 minus 2 is 0.5. So this comes out to be 8, and the units are in feet per second. Okay, so the average velocity from time equals 2 to time equals 2.5, which again is what we're doing here, not from time equals 2 to time equals 0.5, but starting at 2 and going for 0.5 seconds in duration, is this average velocity here. Let's just quickly go through the, so that's what would go in the blank here is 8. Excuse me, let's do the other ones really quick here. So what's the average velocity for the second blank? Well, it starts at time equals 2 and lasts for 0.1 seconds. So this goes from time equals 2 to time equals 2.1. Right, so the average velocity there, I'm just going to subtract the position at the ending time, take that minus the position at the start time, and divide that by the length of time that was in the air. So it's change in position divided by change in time again. Just again to save some time here, y of 2.1 is 97.44 and y of 2 is still 96. We calculated that above. The bottom of the fraction is 0.1 and this comes out to give you 14.4 feet per second. Lastly, so that's what goes here, 14.4. Lastly, 0.01 seconds. I should mention too that since this is web work, you all know that the numbers that you see here, like the 80 and so forth, might have been different for you in your version of this particular problem here, but the calculations are the same. And what you should do is go back and retry this problem and check your answers and make sure you're getting the idea. But let's finish this off here. So what's the average velocity for the last blank? Well, again, we're starting at time equals 2, and the interval is lasting for 0.01 seconds. Okay, so that would end at time equals 2.01. All right, the same calculation, the average velocity is the change in position, and that's this difference, divided by the change in time, and that's this difference. Y of 2.01 is 96.1584, and you can calculate that independently, minus 96, which is still y of 2, and the bottom is 0.01. So this comes out to be 15.84, and that's my answer for this particular blank here, 15.84. Okay. We can now answer this question pretty simply, but just one more time to emphasize this. This is a different phrasing, so the one thing you got to be careful of is you never assume that the problem you're working on is exactly the same as the one you just finished. And the first two on this weren't phrased this way. It was they gave you straight up the starting time and the ending time, and then it was just plug and chug. Here, you do have to really think about the wording here, and don't just apply the same procedure blindly to the next problem. Okay, when it says "and lasting," we have to figure out what that means. And by the way, too, the little critical thinking goes a long way on this. The only way we can tell instantaneous velocity from average velocities is if the time interval is shrinking. And if you use the time interval, you made the mistake I mentioned and said the time interval starts at 0.2 and ends at 0.5, then these time intervals are not shrinking, they're getting bigger. There's more time between time equals 2 to time equals 0.5 is a pretty big time interval to begin with, and it gets larger if you start at 2 and go to 0.1. So we want to be looking at time intervals that are getting smaller as we proceed. And if they aren't getting smaller, then we're not going to be able to tell what instantaneous velocity is. So anyhow, think critically and be careful and read carefully when you see a problem here. It'll save you a lot of trouble. Just to end this off here, what's the instantaneous velocity? Well, we just look at the average velocities and see what they're approaching. It's not totally apparent, but a pretty good guess here would be 16 feet per second, because I went from 8 to 14.4, and now it's beginning to slow down. And if I had to guess a round number, then 16 would be a good estimate there, and that is what the answer turns out to be. All right, so moral of the story here is, keep in mind what it is you're trying to do. You're trying to find average velocities over shrinking time intervals. So if the time interval is not getting smaller, something's not right. And also, just pay attention to the wording here when it says "and lasting 0.5 seconds." You have to always ask the question, what two time points am I talking about? What points in time define the interval? And then once you can parse out the English here, the setup goes pretty smoothly. Please ask more questions if you have them. Thanks.